Greetings all, FerrariMan601 here with my brand new Jensen Model 25 steam engine. Yep. I got this, just came in the mail yesterday. So I've been running it on and off for the last day and a half, and I'm very, very pleased with it thus far. This video is just going to be an overview of what the Model 25 is, what some of its capabilities are, and how to operate the thing. So let's get down to business. For those of you who don't know, a steam engine is an external combustion, in quotation marks, engine that derives mechanical force from the boiling of water and thereby the conversion of water to steam under pressure to, in this case, reciprocate a piston back and forth, turning thermal energy into kinetic energy, and then obviously through a flywheel, branching off to run whatever components you would like to run. So, in order for a steam engine to work, you need a water source, so in this case, a boiler. Underneath the boiler is some means of heating the water. In most cases, it's a fire, but this engine uses an electrical heating element that runs off of 110 volt mains power. You need a way to transfer that steam from the boiler to a mechanical device that turns that thermal energy into mechanical force. So that is through this steam dome and this blast pipe by means of this regulator valve, which is the throttle, by the way, into this cylinder, this horizontal cylinder, inside of which there is a piston, which then pushes this connecting rod to the crankshaft, which is connected to this flywheel, as well as, I'm not entirely sure what you'd call this. It's analogous to a camshaft on an internal combustion piston engine, but it's valve gear. It operates a slide valve, which allows steam to pass from the front of the cylinder to the back of the cylinder, allowing the piston to slide backward and forward in its intake and exhaust strokes. Obviously, steam is intaked from the steam pipe into the cylinder, which forces the piston to be blasted back, turning the crankshaft, and then the kinetic energy of the spinning flywheel pushes the piston back up to top dead center, which then forces exhaust steam out through the exhaust pipe here. So that's how that works in a nutshell. Now the Jensen Model 25, it is one of the most powerful hobby steam engines that the Jensen Manufacturing Company out of Jeannette, Pennsylvania manufactures. And it's my second Jensen steam engine. My first one was a Model 60, which you can actually see right here. This one runs on dry fuel tablets. I'll do a proper video on this engine when I can. It still has some problems, but I actually fired it up on Steam for the first time in over 10 years this afternoon, and I did get it to kick over, but I have a leak between the cylinder and the valve porting. But this is my Model 60, runs on dry fuel tablets. You can see the firebox there, and same basic controls on the Model 60, but we're focusing on the Model 25 for the moment. So here it is. In order to operate the engine, I should tell you I've already filled the boiler with water, and I just burned myself there. I've preheated the boiler as well, so we won't have to wait too long to build up some steam. Here is a safety valve. It's just a poppet valve that goes off at about 24 psi. In case the boiler overpressures, this valve will pop open. It has a poppet action. If I can show you like that. There you go. And then we can put the safety valve in its place on the boiler. But there's a funnel that you would be pouring water through the hole where the safety valve mounts on top of the boiler. And that's how you would fill it. Run the engine on distilled water, and I've just turned the heater on, so we're going to start to build up some steam. On top here, this is the whistle. So right now the whistle is open, and you would close it by pulling the lever down to 90 degrees. So that's cool. You might be able to hear the boiler starting to build up some pressure already. We'll close the whistle down so we can maintain the steam pressure that we're starting to build. This, as I mentioned, is our throttle. So this controls the flow of steam through the steam pipe from the boiler to the cylinder. And then this final lever here is our reverser. This is a 2-speed forward and reverse engine, so it will drive the flywheel clockwise and counterclockwise. Flip it up, And you can see the eccentric, the forks here from the on the valve guide there. So this is the so if I can show you the mechanism, so you can see how the mechanism operates. And all it does is it moves the valve slide fore and aft ever so slightly. You might be able to catch that there. Just changes the valve port order. So then the rear one is the intake and the front one is exhaust and vice versa, depending on whatever position you have the reverser in. I don't have it hooked up right now, but there is a power takeoff on this pulley right here, and this is a little fake governor that you can run. I'm not running it right now, but you can see all of that. Now normally when we're waiting for the engine to heat up, I've already done this for our purposes here, but just to demonstrate, you want to oil the engine. And when we oil it, we want to hit all of our major moving parts. So our crankshaft, our valve gear, both on the crankshaft and on the eccentric, so all of that. Handle for the valve gear if you want. Our connecting rod bearing, so a rod bearing there on the piston. The con rod, main section of the con rod before the articulated joint. And then of course on the support frame for the flywheel in the rear. And you can just give the engine a couple of spins to distribute some of that oil around. So things are starting to bubble away here. You can see some steam shooting out from between the slots in the regulator pivot point. So we are pretty much ready to start the engine. I'll move the piston reasonably close to top dead center. And we'll open the regulator and we should have a decent head of steam almost. Water in the watch glass there. You can see it's just coming to a rolling boil now. Here's the whistle. So that's awfully loud. It will make every dog in the neighborhood very crazy if you happen to have your windows open. So, open the regulator, give the engine a spin. We'll purge some of the water out from the cylinder because liquid's non-compressible, and then you can see the engine starts to kick over. You can see a lot of condensation coming out of the exhaust pipe here because the piston and cylinder are coming up to temperature as the hot steam reaches the relatively cool cylinder. But now the engine is kicking over smoothly, and we can even slow it down more than that. So you can see everything running very, very nicely. Relatively quiet operation at low speeds, but we can really open it up if we want. So we're going to go to full power. That's full. And you can tell that this thing really, really will go. I'm having to hold it in place because it's walking itself across the table right now, but it has quite a motor on it. Just having to rest my hand there on the table to get some leverage to close the throttle down a bit. The engine's also reversible, which I'll demonstrate now. Open the caps a little more. And there we go, the engine's now running in reverse. And of course, I find that the engine seems to be a little bit more belabored when it's running clockwise versus counterclockwise. See, counterclockwise. Comes up to speed a bit more quickly. Clockwise. I don't know if that's because the eccentric is in a raised position when the engine is running clockwise or what, but it seems like it's putting out a little bit more effort for the same return when it's running clockwise versus counterclockwise. In any event, you can see the safety valve here is just starting to pop off a little bit. As we're getting close to our relief point. You can see a little bit of leak around the base of the whistle as well. Just paper seals around the base of the whistle. We're not totally airtight here. It's got some very, very, very cool capabilities here with this engine. It's just really cool to watch it work. And in case if you're wondering why there's a shot glass here, I use this to measure the amount of distilled water that I pour in, because putting a gallon jug of, trying to pour out of the gallon jug of water straight into the boiler is a little bit of acrobatics that I don't necessarily need to perform, so I'd much rather do it that way. And you see the engine will just be very happy to run at a relaxed pace like this, and it'll even self-start when you throw the reverser, even at lower speeds like we see here. So very, very cool. Still reasonable amount of condensation shooting out from the exhaust. It is what it is. And the little poppet you see coming in and out of the block there is the valve slide. Just love watching this engine work. It's very intricate, but very simple at the same time. Very unique piece. I like it very, very much. It's also very nice to listen to. We'll stop the engine for a moment. Turn off the heater. We'll dump a little bit of pressure, because I want to hook up the governor just to show you how that operates as well. It runs actually on a spring that functions as a drive belt, but need to dump some pressure before I can hook that up, just to control some heat so I don't burn myself too badly doing that. And while we're on the subject, you'll see that I've removed the safety valve. I'll show you the filling procedure. And the boiler is still pretty hot, but again, it's not the best practice. But here's your funnel that comes with the engine. Goes in where the safety valve is secured, and I use a shot glass. You don't have to use a shot glass, but in it goes. Make sure the whistle's open just to vent the displaced air, and then check your sight glass, and you'll see that the water level is pretty much at the midline in the sight glass, which is exactly where it should be. So, remove your funnel, and then my safety valve is still rather hot, so I'm going to try and make this quick. And you screw the safety valve back into its position, securing it reasonably tightly. So that's how you refill the boiler. And just so you get an idea, this is the spring that I was referring to, the drive. It functions as a drive belt between this grooved flywheel before the main flywheel and the flywheel on, or the pulley rather, on this pseudo governor. So we're gonna loop this around the main flywheel, secure it through the tiny eyelets on either end. I don't know if you can see that, probably not, because the camera won't focus in that closely on something that small. Whatever, but you get the theory. Okay, so we have hooked up the drive spring belt device to the power takeoff there, and to the to the pulley on the fake governor thingy. So you can see the linking joint there, left of center in the picture, and the heater is on. The boiler is starting to come up with some pressure, so we're going to close the whistle off. And then I will show you how the engine will drive the governor. By the way, you language nerds, I'm sure you've heard of the expression balls out. It has nothing to do with the male reproductive system. Instead, it refers to the days when steam engines, bigger versions of this basically, used to run everything from factories to power plants. Actually, steam engines still run power plants in a lot of places, but term balls out meant that these governor devices, you can see that the governor, these, I don't know what you call them, paddles? they are free to swing in a direction perpendicular to the main axis of rotation. And obviously, as the rotation speed of this governor increases, the centrifugal force will cause these paddles to swing outward. Those of you who know anything about basic physics or figure skating will know that when an ice skater puts her arms out, her spin slows, and when she tucks her arms in, she speeds up. Same sort of principle here. I don't know what exactly the principle is called technically, but I know that when mass is farther away from the axis of rotation, the speed of rotation slows. So that's the theory going on here. It seems like we have a bit of steam coming up. See in the watch glass there, the boil is happening. We'll go to turn counterclockwise. We'll have to purge the condensed water from the cylinder, as we did before. Let a little bit more steam build up. Just trying to warm up the cylinder again. Loses heat relatively quickly compared to the rest of the engine, particularly the boiler. That's why that condensation occurs. But almost skipped over. There we go. So you can now see, I'll slow the engine down to just barely ticking over, which is about here. So you can see the belt from the flywheel to the governor. It turns 90 degrees in relation to the flywheel, so there's a bit of a twist in the belt there, but none of the parts overlap, so it's a smooth rotation. You can see the engine really does not even notice that that governor is attached, and the RPM that it can achieve is not affected by the presence of that governor in any appreciable amount. I certainly can't hear a difference with or without, so that governor really doesn't do anything functional. It's just a showpiece, basically, just to show that the engine can actually run something. Close the taps down a bit. Back to a happy idle speed, and it'll still reverse. Leave it a little help. It'll still reverse with the governor attached. Engine seems perfectly happy running in either direction, as it did before. And to conclude this video, I'll leave you with some gratuitous slow motion shots taken with the engine running at a very high RPM, and I'll be showing you the belt drive mechanism there, just so you can see the oscillation that appears to be occurring at the high speeds. Looks like a blur. Looks like a blur to my eyes. I don't even know if the camera's picking it up, but I can definitely see oscillations occurring on the top section of the belt drive at higher RPM, so I'll leave you with some slow motion shots of what that looks like at 240 frames per second at that high RPM, which happens to be full throttle. But before I do that, I want to thank you very much for watching, and I will see you soon.